Hi again, math friends. We're going to look at section 8.6 today, write and graph inequalities. Before we just kind of talked about inequalities, but now we're going to see what do they really mean in the real world sense. Let's say you have watched more than 4 video lessons. What numbers could we use that could be possibilities for more than 4? Well, 5 is more than 4. Is anything else more than 4? 6, 7, 8, 9, and 10. You should start to notice a pattern here. It looks like we would start at 4, but 4 is not more than 4. So let's start at 5, and everything to the right here is more than 4. Let's also look at another example. I like to have at least 2 scoops of ice cream. Remember, at least, can I have 2? Is 2 at least 2? Yeah, that means that it is 2. It's equal to 2. Is 3 at least 2? It sure is. It's either greater than or it's equal to 2. 4, 5, and again we notice that pattern. Once we find out where we need to start from, we need to have at least 2 start at 2, and then we can go all the way up. What I'd like you to notice though is that, remember, numbers don't just stop. 10 is not the highest number ever. Numbers go on forever. So this could go on infinitely. With our next couple of examples, we're going to actually write the inequality. We need to use some sort of variable to represent this. Let's say S represents the students that are in class. We have to say that there's more than 17. So what we're going to do is we're going to use S is greater than 17. And we can try to plug in different numbers to see if that really makes sense. If we choose 20 for our number of students, 20 would be greater than 17. And that fits our numbers, that fits our sentence here. There are more than 17 students in class. Let's pick another number higher than 17. Let's pick 18. Is 18 greater than 17? Yeah. That's how we can check to see if our inequality actually works. In the second example here, where we have to write an inequality from a word sentence, I have $20 at most. I have $20 at most. That means that I don't have anything higher than $20. So let's have C represent the amount of cash that I have. And we're going to say C is less than or equal to $20. $20 at most. Remember, that means that I don't go over, and that means we're using the less than or equal to sign. Now we're going to put the two together. We're going to use a number line to show what possible solutions we could have for each inequality. Let's start here. X is greater than 3. On our number line, let's locate where 3 is first. 3 is over here. Since we have a greater than symbol, we're going to draw an open circle. And greater than 3, does that mean we go to the right of 3 or to the left of 3? That means we go to the right. We're going to show that it goes to the right. At the end of our number line, we know that numbers go on forever. Remember, numbers here do not end at 8. We're going to draw an arrow in there to show that it would keep on going forever. Let's look at another example. X is less than 4. We're going to find 4 and draw an open circle there. And then we're going to draw a line going, X is less than, so we're going to draw it going this way. To show that everything less than 4 is a solution. Notice in here we don't have just whole numbers. Everything that's in between the whole numbers works too. If we said X is greater than 3, 3.5, yeah, that's greater than 3 also. 3.1, that's also greater than 3. If you have a really tiny decimal like 3.00001, that's also greater than 3. We're using the open circle to show that X is never equal to 3 though. Here's some different kinds of examples. Here we have the greater than or equal to sign, less than or equal to, and another less than or equal to. Notice the difference in the ones that we had before. Here we have X is greater than or equal to 1. So we're going to find 1. And since it could be equal to 1, we're going to draw a closed circle on there. So make sure you color in your dot or your circle in there. And x is greater than 1, we're going to go to the right. And remember, draw that arrow because it could go on forever in that direction. In our next example here, x is less than or equal to negative 2. Let's find negative 2 on our number line. If we're not sure, remember we can start at 0, and then in our negative direction, we can go left 2 spaces to negative 2. Since it says could be equal to, we're going to draw a closed circle or a dot on there. X is less than. So which way should we go, left or right? We should go to the left. And draw that arrow at the end to show, yeah, this could definitely go on forever. In our final example, we have a different scale here for our number line. Always make sure that the number line that you're given has a scale that you can work with. Or if you make your own, that you can work with it properly. So here we're going by tens. 10, 20, 30, 40, 50. Okay, that makes sense. 60, 70, 80, 90, 100. Okay, so every dash is a 10. X is less than or equal to 70. Where could we find 70 here? Well, here's 50. It goes by tens, 60, 70. Since we have that equal sign underneath, the less than or equal to, we'll draw a closed circle. And it's less than, so to the left or to the right? I'm going to definitely go to the left. That's showing that every solution in here could be less than 70.